Greetings, everybody. This is Timur, and we welcome to our webinar, Migrating to exabyte.io and digital collaboration. As we are entering the state of lockdown, most of the people in the world are on lockdown because of coronavirus. It is important for us to have an efficient way to collaborate while we are sitting at home. And that's why I wanted to speak about digital collaboration specifically in this seminar. Right, let me share my screen here and let's go ahead. Again, if you have any questions at any point in time, please shoot me a quick email at timur@exabyte.io after we're done. Or during the scope of this webinar, please put your questions in the chat. The goal of this webinar is to help users understand what exabyte.io is and how to benefit from using it. This is the second webinar in the monthly recurring series. First Friday of the month, we speak about getting started with the platform. And third Friday of the month, which is today, we speak about advanced topics. Every participant should be a registered exabyte.io user. And every participant will receive this presentation in a PDF format after the webinar. Highlighted text contains a link to a web page. Some figures are links as well. This webinar is recorded and will be made available online. And all information that you can find here is also available in our online documentation. If you have any questions, again, please feel free to use either the chat functionality or the Q&A functionality to ask them. We'll have specific Q&A breaks during this webinar, and I will try to answer questions as soon as we have them. We'll assume that the user is an experienced computational material scientist, familiar with tools like Quantum Espresso, WASP, or similar. We'll assume that the user understands the basics of Linux and Unix operating systems and has an established set of scripts and input files to perform calculations with these packages. And the goal of the seminar essentially is to help people migrate the scripts and input files to the exabyte.io platform and explain how to work collaboratively with other scientists online. There are two options for migrating to our platform. First, users can entirely bypass the web interface and use alternative connection methods to access command line environment and reuse their existing scripts and input files. This is a very quick way to start, but most of the time we see that this editing input scripts is error prone and it's difficult to reuse and share them. The second option, and the one that we'll be looking into in more details, is to adopt the exabyte.io platform approach to create the entities like materials, workflows, jobs, and such. This requires user to understand the approach and learn it, but it is reusable for multiple materials and it's easy to review and share this data. So consequently, the options for collaborating within the exabyte.io platform are also two. Either users can bypass the web interface and collaborate using our shared file system. I will explain it a little bit more in details during the webinar. Or the users can adopt the exabyte.io platform approach and view and edit materials, workflows, and jobs collaboratively either within one organizational account, one team account, or they can share and edit the entities with other accounts. So if I'm a personal account user, I can share it with somebody else, some other person in the world, and collaboratively work on doing simulations, editing materials, and such. And the third option is to share entities publicly on the web. This is similar to the digital object identifier for publications. We have specific URLs for each entity, material, workflow, and job. And these are permanent, so users can relate to them and cite them. Again, this requires learning our approach, the platform approach, but it is intuitive, easy to use, and minimizes errors. Here is the agenda for today we'll speak about the platform infrastructure. I will explain about the file system and how it can be used to share data. And then I'll speak about materials, how we can migrate structural information from PWSCF input to the exabyte platform. The same about simulation workflows. And then I will show how to run calculations and how to share them, right? And then I'll speak a bit about the organizational accounts and how the sharing works within them. We can make all webinar participants to use the webinar account to try the functionality that we are discussing today. And this account has advanced features enabled for it, like command line access. During the webinar, we'll look at recorded videos to save time. And attendees can follow this presentation using the PDF that they will receive at the end of this webinar, and do repeat these actions on their own. Okay. All right, so let's go and discuss the platform infrastructure first. Here's the architecture of the platform. It's a distributed web application with multiple parts. The important parts to the user, oops, I apologize. The important parts to the user are highlighted here in the top part, excuse me. And those denote the remote connection methods. So most of the time, users connect through a web browser online. Alternatively, they can use secure shell or remote desktop or a web terminal. And for these three connections, they are diverted to the login node, and that's how they can communicate, perform actions on the exabyte platform. So secure shell connection is based on a key pair and requires an SSH client, such as putty or terminal on Mac. Web-based command line terminal is equivalent to SSH connection and can be started from the web. No client is needed. And the remote desktop connection through a web browser is essentially a connection to a CentOS Linux system on our infrastructure, providing the same functionality that any Linux system would provide, with graphical tools like Vesta, Xquiston, NanoLabo, and such. There is also a way to connect to the platform through RESTful API, but we will not be going through this in details today. For the SSH connection, one would have to upload a public key and then use any terminal to connect. Here's a brief snapshot of the Preferences tab, where users can upload their keys. For the web terminal, users can connect directly from the web. So they can open the right-hand sidebar and then click on terminal here to connect. The similar action can be done for remote desktop as well. They can connect through remote desktop by using the remote desktop option inside the right-hand sidebar. All right, this is how it looks. So what's important to understand is that when users connect to the login node, they have access to multiple clusters. And these clusters, they can reside on multiple computational systems. So cluster 001, for example, right now is hosted on Amazon Web Services. There's cluster number 7 in production that is hosted on Microsoft Azure. And the data that they produce on all these different computational systems is aggregated on the login node. So under the corresponding mount point, under username, inside this mount point, we have the data coming from each of these clusters. And for organizational accounts, there is also a way for multiple users to access this data. And that's how they can collaborate. This is how they can see each other's work. And remote connection methods, again, are establishing connection to the login node. When users connect to the login node, they can see shortcuts for each of the computational clusters. This is how it looks for my account, for example. I have shortcuts to cluster 001, cluster 007 in production, and I can navigate into each one of them to see what I've done in each of the systems. There is also a link to the organizational account inside the cluster home folder. So when I navigate into the cluster 001 folder, I can see that there is exabyte.io link, which can take me to the folder that is shared between all team members, all users that belong to exabyte.io account. And that's how we all can create data and share it with each other and get access to the same files. All right. Now, there is also a Dropbox folder that is accessible on multiple parts of the infrastructure, on the computational master node, on the login node, and on the web interface as well. We mean it as a hot cache folder. So a folder where people can put some small data that need to be accessible throughout the infrastructure, both on the web interface and on the master node and on the login node. Examples could be Python scripts or shell scripts, pseudo potentials, Jupyter Lab scripts, and such. Some small data that needs to be accessible throughout the platform lifecycle. There is also the user data folder that organizes the calculations that are performed through the web interface. And this data folder is inside the user home folder. And each calculation that originates on the user interface on the web is stored inside this data folder with a certain naming convention. As you can see here, let's say we have a user whose name is Steven, username, and they're working inside the project default. So the Steven-default folder will contain all the jobs that belong to that project. And the job names will be named in the computer-friendly format. So on the web, we'll see new job November 11th with spaces. And in the command line infrastructure, we'll see new -job -November -11, right? So this will be computer friendly, and at the end we also add the database ID to uniquely identify these folders. For the organizational accounts, their corresponding data folders are present under the share groups folder. So if we work within the exabyte-io account, it will be under cluster 001, the share/groups/exabyte-io. All right. What's important to understand is that all the data that is produced on through the web interface can be accessed on command line and vice versa. So if there is some functionality that we do not yet support on the web interface, but there is a way to access the data that is produced through this web interface, there is a way to use this data through the other tools that are available through remote desktop, for example, or through command line. Here is a demonstration of it. We do not yet support the visualization of the Fermi surface through the web platform, but we support it on the remote desktop, and that's how users can access a specific file inside their calculation and visualize the Fermi surface using that file. Okay, so here's a brief summary. The remote connection is an alternative way to access the Exabyte platform. We can enable it upon request, and it's enabled by default for organizational accounts. There are three options: web terminal, remote desktop. Both of these are inside the web browser, and a secure shell connection. Remote sessions are connected to the login node with a separate home folder for each user. Home folders have links to directories for each compute cluster. An important note for the people who will be running command line jobs is that they must be submitted from within a cluster directory. So we have to navigate into cluster -001 and such in order to be able to submit and run command line jobs. And there is a variety of software packages available both via remote desktop and via command line modules during this alternative connection scenarios. Okay. Let's see if there's if there are any quick questions. It doesn't seem so. All right. So let's go forward and let's speak about the materials in particular and how we can migrate the information from PWSCF scripts input files to material entities inside the Exabyte platform. Here we will start with Quantum Espresso PWSCF input files. And as you can see, there are two, the self-consistent field input file and the non-self-consistent field input file. And we will use both. I apologize. I'll mute myself for a second. All right, the ambulance had passed, so we can continue. These two input files represent the self-consistent field and non-self-consistent field calculations that usually executed in a chain. So first SCF, then NSCF. And they contain both material and workflow information about the system that we're studying and the simulation approach that we use. So what we'll do right now is we will extract the material information and post it to the Exabyte platform to create a material entity. Initially, we have to look and identify the material information within the file and note a few important things. Like this material has a certain crystal lattice and certain crystal lattice parameters, like the cell dimension 1. And there are also lattice parameters over here, right? So we need to note what they are. And we see that there are atomic positions for the crystal bases given in the crystal coordinates. And this is also important. So we need to note all of that. And then we'll open the platform and click on the plus button to start Materials Designer session. It opens by default with silicon as the default template material. What we will do now is we'll clone this default material and remove the original one and adjust its name. Right? We will use silicon template to create a new material. Next, what we will do is we'll set up the crystal lattice parameters using the corresponding form. First, we open it, and then we need to understand which lattice parameters to use. Right? This is a triclinic lattice without any specific symmetry. We will not assume any. And then we will note the cell parameters. It looks like it's a cubic cell with a certain Z dimension and X and Y dimension equal to each other. So we'll copy the cell dimension, we'll convert from board to angstroms, grab the value in angstroms, and put it into the lattice parameters for A and B. Then change the angles. So we will multiply by the factors 2.3 to get the lattice parameter in Z dimension, and then we change the angles, right? So now, with a little bit of work, we have the lattice parameters set up. And so now the next step after that would be to set the crystal basis parameters. And that is easier. Here, we just copy the original crystal basis into the corresponding form. And there we go. So here we have the crystal basis and crystal lattice migrated from the original PWSCF input. And we can see and assert that this is indeed the material that we wanted to look at. All right. The next step is to save the material structure. And we can do that by opening the input-output menu on top. And usually it's a good practice to tag materials so we can quickly find them in the future. So I'll put from PWSCF as a tag. And I will save this material by clicking save. At the end, when the operation is successful, I see the corresponding pop-up. And when I come back to the list of materials, I will see this new material created in my collection. Okay, so that's how we can migrate the information from Quantum Espresso PWSCF input to a material entity in the exabyte platform. There is another option where we could use a third-party converter. We do not support importing the information directly from the input file, but we do support input from POSCAR and CIF formats. So what we can do is we can use this converter routine to convert the materials information from XYZ that is stored inside Quantum Espresso into POSCAR format. So it will only contain the structural information without anything that is related to the simulation workflow. And we can use this POSCAR file to upload it through one of the platform actions. I explained that in more details in the Getting Started webinar, so you can see one of the prior recordings to understand how to do that. Now, dealing with workflows is very similar. We will start with the same two files. And here, instead of looking at the materials information, we will be focusing on the information about simulation workflows. And the first step here, again, is to inspect the input files, make sure we understand which parts correspond to the workflow information. And then we go to the Workflows tab in our account and click on plus button. I do apologize, there are a lot of additional sounds today in this webinar, but hopefully it doesn't disturb you too much. So let's go ahead and create an empty workflow, right? So we click on the plus button in the Workflows tab, which takes us to the empty workflow in the Workflow Designer. Then we edit the name of its subworkflow. You can do that in the header. This is the workflow name. Below is the name for its first subworkflow. By default, the new workflow is empty and it only contains a single empty subworkflow. So I'm calling it the SCF and SCF subworkflow. All right. And then I'm adding a unit to this subworkflow. I need to make sure that the application is the way I want it to be. So Quantum Espresso, that the model and method are properly set with the right functionals, for example, for pseudo potential. And at the bottom, I'm clicking on plus unit to add a unit to this first subworkflow. I click apply. And then I go inside this unit by clicking on it. Inside this unit, I can see its properties. So by default, we add PWSCF unit that has pw.x as executable and pw_SCF as a flavor. So that's exactly what you want for the first part of this workflow. We want the self-consistent field calculation, which has certain properties that will be extracted from this calculation. It has certain monitors, like electronic convergence will be monitored during the scope of this calculation. And at the end, at the bottom of this file, at the bottom of this web page, we see the input file, the template that we use for the self-consistent field calculation. Now, our next step is to take the two, the template and the original input file that we have, and compare them. Here, we'll see that there are a couple of, a few extra flags that we need to add to the template. And this is exactly what I'm doing. So I'm replacing the verbosity with the one that was in the original input. And I'm adding the LK point _0 and disk.io as well to match it with the original input file. Then I'm looking at the system name list and changing the smearing. Okay. And I'm looking at the electrons name list and changing it to what it used to be in the original input file. Note that I'm not touching anything related to the atomic positions or atomic species or cell parameters, because that is entirely up to the material that we will be working with. So we use the variables here, Ginger variables, template variables, to be able to cover multiple different materials. This template would work with multiple material structures, depending on which structure we choose from our collection. And that's the powerful part about using the templates, because here inside the input file, we have the materials information frozen. We cannot easily adjust it, but inside the template, we can quickly populate this information based on the database entry. All right. Now we can see that there's material information coming from the default material, like there is atomic positions for silicon, which is our default material. And we can preview this template using this material information, as you can see under the preview tab. All right, just to make sure that this input template, in fact, looks the way it should. My next step is to repeat these steps that I just did for the first unit with the second unit, with the non-self-consistent field unit. And that's exactly what I do. I create another unit here. It's going to be PWSCF initially, so I need to navigate into it and change its flavor to PWNSCF to get the right template and the right parameters for properties, monitors, and such. Now I go into the input file, into the template, and I adjust the corresponding name lists by hand as well. Okay, so adjust each of the name lists directly. And one could think that that's a laborious procedure when we first created the workflow, and it might as well be. But the good part about it is that we only have to do it once. Unlike when we work with input files directly, we always have to adjust the input files each time when we run a new calculation with a new material. Here, we only need to set this workflow structure once, and then we can reuse it with multiple materials while running calculations. So the next step, step number 6, is to save the workflow, and for that I'm clicking on this save button in the header. First, I'm changing the name of this workflow, and I'm adding a tag to it from PWSCF, just like for the material, to quickly find it in the future. And then I'm clicking on save, and now I see the workflow inside my workflow collection. This is the new workflow that I just created. And if I navigate back to it, I can see the input files for it, the units that I've just created, and such, right? So that's how we can create a workflow from the PWSCF input files. Now, the second option is becoming more and more available, more and more common as we grow the number of users in the platform. Today we have about 1,000 users, and the likelihood of them already, the likelihood that they have already worked on something that you will need as a new user is very high. So what we suggest people do, especially new users, is to go and search for the workflows that they want to run inside the workflows bank. And they can do that by navigating by opening the left-hand sidebar and clicking bank, then workflows, and then searching for the property that they want to calculate. For example, if they want to calculate the electronic band structure, we'll search for the band structure, and they can copy one of the workflows that are already available inside the workflows bank. Here, I have an important note to use initially, especially when you are just starting with the platform. We suggest using the workflows that have been created by the curators account. Curators is a special account that only exabyte team administrators have access to, and we make sure that the workflows that have been created by this account are high quality, and we suggest using those in the first place. Once you get familiar with them, you can look through other people's workflows and copy them as well. All right, so when you copy the workflow, it appears under your account's collection list. Okay, let's see if we have any questions at this point. I'm not seeing any yet. Nothing in the chat. All right, let's go and look at how we can create simulations using the materials and workflows that we just created. The option number one is to bypass the user interface and use command line. And that's the option that we have discussed in the previous webinar in details. So I will not be speaking about it today. And once you receive the PDF, you can click on the links here and navigate to see how this can be done. I will explain how we can run a simulation inside the platform, inside the web interface, using the material and workflow items that we have just created. So steps number 1 and 2 are those that we have already covered, where we create a material and we create a workflow for this simulation job. And this is an important note to understand. We on purpose separate these entities. Materials, workflows, and jobs are completely separate. And without having a material and workflow, there is no way to run a job. To be able to run a job, we need to navigate to a project. If we try to start, create a new job inside the jobs list, we'll get a warning to navigate into the project first. And that is done to organize the work, organize jobs into batches, into projects that could be dedicated to specific materials. For example, each account by default has a default project and an external project. The default project is where the calculations are run by default. That's understandable from its name. An external project is where the external data uploads would go, creating new jobs inside this project. So if you upload existing data from VASP or quantum specific calculations, it will contribute to new jobs inside this project. So now we will navigate into the default project and click on the plus button to create a new job. And step number 1, or step number 0, actually is to change the job name to be able to find it in the future. And I'm dealing with calcium tungsten 04. So I'm changing it to contain the name of the material. And now I am selecting the material as step number 1. I'm clicking on select materials dropdown in the header. And I'm selecting the corresponding material from the list. Now we can see that it indeed has been added to the job designer. And step number 2, I'm selecting the workflow, the one that we just created, and applying it to the workflow designer too. So now I have the material and the workflow inside the job designer. Step number 4 is to inspect the workflow. Sometimes when we deal with the calculations, we want to adjust certain parameters for the workflow. And this should not be any fundamental parameters like the logic that has the workflow has inside itself, going from SCF to NSCF. We do not allow to edit that inside the job designer. But what we can do is we can adjust certain parameters that are specific to the calculation itself. For example, there is a certain key point sampling, or the number of points in the reciprocal space that we use to sample this calculation. And that we can adjust inside the important settings tab in the workflow dialog. So if we go to the important settings tab, we can change the PWSCF key grid parameter, which is what I'm going to do right now. I'm going to use 4x4x2, just as I had it in the original input file. And I will use 8x8x6, I think, right, for the NSCF unit. Again, these parameters are grouped by unit. So PWSCF has certain parameters available for adjustment. And I'm also reflecting that I have edited the key grid inside the name of the job to be able to track it in the future. Next step is to change and set up the computational parameters. And this in itself could be a subject of a separate webinar, because there are a lot of moving pieces and there's a lot of complexity in how we can select these parameters. But for now, I will just use the ordinary regular computational queue, resource queue. Looks like I have to mute myself for a few seconds. All right, the ambulance is going again, so we can continue. I apologize for the interruptions. I think it's we're living through some difficult times, and that might be another confirmation. So the computational parameters, for now, I'm just going to use the ordinary regular queue with 1 node and 18 cores per node, which is what I would recommend for any production type calculations. This would be the starting parameters. And I will use the AWS cluster 001. And I will select to get notifications for all updates regarding this job. Next step is to save this job. For that, I'm clicking on the checkmark button at the top. And when the job is saved, I can see this job inside the list of jobs for this project. Here it is. It's in the pre-submission status, light blue. Then I'm selecting the entry for this job and clicking run to run it. Right? What happens after is that the job is being submitted. So its status is changed to be S, which means submitted. Shortly, you can see that there's an estimate for when it will actually start running. So now it's held in the queue when it's submitted. And then within the 10-minute period, it will start running. That's what the system predicts. Usually it's less than 10 minutes. You can see within 2 minutes, the job becomes active. And now we can navigate into the job by clicking on it. We click on its name here, we'll navigate into it. And if we go into a PWSCF unit, which is now highlighted in orange, meaning it's the currently active unit, we'll go into it. We'll open the output to see the output of the job, which is updated in real time. If we open the charts panel, we'll see the convergence graph, also updated in real time. We need to make sure that the job is indeed converging. The graph is going down. And when the first unit is finished, it will turn green. And the second unit will turn orange, meaning that the second unit is actively running at the moment. Here we can monitor the second unit's output to see how it progresses. And since it's a production calculation, it will take some time to go through all of it, right? In fact, I think it took about 10 minutes, right? About 5 minutes, something of that sort. Yeah, 6 minutes to be precise. So at the end, when the calculation is complete, both of these units are turned green. And we will see that there are 2 extra tabs added at the top. We only had materials, workflow, and compute initially when we created the job. Now we have results and files. We can navigate to the results and see the results per each unit here. So we have things like Fermi energy or pressure and forces on the structure. And we can also navigate to the Files tab to see all the files that this calculation produced. And we can download these files, we can preview them all from the web. All right, so that's how we can see the results and the files that belong to a calculation. And we can also see the cost, how much it costs us to actually run this calculation by clicking on this link. Now, when we have this calculation finished, the optional step is to share it with someone else, right? Here, I've been running this calculation under the webinar account, so the account that we can use for the seminar. And I'd like to share it with my personal account. So when I log in into my personal account as Timur, I can still see this calculation. What I need to do for that is to open the dropdown for this job and then select the share action, which opens a new dialog. Here I can see which accounts this job has been shared with. You see that the job is public, and that's because that's the setting for the webinar account. All its jobs are public, so they're available to all the platform users. They can be seen by all the platform users. And now I'd like to also add myself to the list. So what I do is I select myself in the list and I click on the read permission at the top. So now I will get the read permission on this job when I'm using the platform under my personal account. Okay, now we see that the job is shared, which it wasn't before. So when we started, there was no checkbox under shared, checkmark, and now there is, which means that this job is directly shared with another account. Okay, I will demonstrate how to access the shared with me tab in a moment. Now, just some key takeaways for the simulation job. Again, there is a way to run jobs through command line, and it's a quick way for anybody new to start. There is a quick way to start through using command line interface. But there are certain things that people will be missing out on. And these are the reusability, the ability to run calculations for multiple materials at once, and the ability to share this information. So for the user interface originated jobs, we can deal with multiple materials at the same time. The data is automatically organized in the database online, and it's much easier to collaborate, to share and see what other people are doing. And I will focus on that in the remaining part of this webinar. Most people use a limited number of workflows, and essentially what they have to do is just to set up maybe 2, 3, 5 workflows at most, and then they can adjust them as they create the simulations. So really the barrier to start is not that high, and we're willing to work with all the new users to explain how to do this, and that's the whole point of having webinars like this too. So we incentivize users to migrate their existing scripts on input files to reusable workflows in our platform instead. Now let's talk a little bit about the sharing and collaboration a little more in details. So first, it's important to understand that there are personal accounts and there are organizational or team accounts. And your personal account is unique, meaning that every person has their own personal account and they should not be reused between multiple users. So this is against our policy. So one human, one person has to use a single account. It's like a Facebook account in a way. But there could be multiple organizational accounts. So if you're a member of exabyte.io team, then you can access the platform, as I will demonstrate, as a member of that organizational account. Since I'm also a member of the seminar account team, where many other people are also members, I can select to use the platform as seminar account member as well. So what one needs to do is to open the sidebar, right-hand sidebar, and then go to my accounts to see all the accounts that are available to this person. Then I can click on seminar, and when I do that, I start using the platform as the seminar account member, which means that I'm seeing all the materials, workflows, and jobs that belong to that account. All right. And accordingly, the bio information also reflects that. when I'm done and I want to come back to my personal account, I can go back to my accounts list and select my name there to come back. All right, so that's how we can switch between the accounts. Now for organizational accounts, we have role-based permission scheme. And the role-based permissions, they have teams at the core, which means that we can add people to account. So organizational account can have multiple members, and these members can be added through the people tab of the account. If we go to the people tab, click on plus, we can add multiple other users to this account. And initially they are added as regular users, so they are not administrators, as we can see. In order to give this newly added users access of a certain type with a certain permissions, certain kind of permissions, we have to establish a team. So we need to create a team under this account, which we can do on the Teams tab. We click on the plus button again and name this team test team. This is an example team, and we need to allocate a certain set of permissions to this team. There are 4 different kinds of permissions: read, edit, comment, and execute. Comment and execute right now are placeholders, but read and edit are production-ready permission types. So we can create a team that can only have read permissions on the entities that we add to it, such as materials, workflows, and jobs. Or we can create a team that will be able to edit those entities. And that's what I'm going to proceed to do. Actually, no, I'm creating the team that only has read permissions. Okay, so I have created the team. Now it has 0 members. Now I can add members to this team. So go back to the team, open it, and on the people tab, I can select some of the people that I have just added to this account. All right, so now these people are members of the test team that has a certain set of permissions. In this case, this test team now has read, edit, comment, and execute, so all 4 different permissions. And these people will be able to read and edit all the entities that belong to this team. Right? So if I select specific entities now and add these entities to this team, like what I can do with the material, I will have the people that are listed on this team to have these permissions on this material. So we have to explicitly add entities to the team to be able to assign certain set of permissions on these entities to the people inside the team. And that's the role-based permission scheme that we use to be able to delegate administrative permissions, edit permissions, and to make sure that there is certain hierarchy and structure. Now, there are certain access levels that entities can possess. So there are permissions and there are access levels. Access levels mean that entities can be shared with no one. So this is what we have by default for accounts that have private data. Only the users, the members of the specific account can access this entity. Alternatively, we can add this entity to be accessible to another account, which is what we call shared with another account, shared with all other accounts in the platform, which is what we call public. We can share this entity with anyone with a link. This is similar to how Google Docs work. We can have an obscure link, send it to someone, and the someone will be able to see this entity without logging in, without creating an account in the Exabyte platform. Or the last option is to share this entity with anyone on the web and make it searchable by search engines. So it will be searchable on Google. So what we need to do to establish this set of permissions, I will demonstrate here. So first, let's share this entity with another account. And for that, I'm selecting this account from the list, giving it the read permission. And now I have the check mark here. Second, let's share the second entity with all other accounts. And for that, we're going to need to share it with public. I'll add the read permissions to the public. And now everybody in the platform will be able to find and see this entity, this job. The third job I'm sharing with anyone that I can send the link to. And for that, I'm selecting anyone with a link. Right, and now selecting read again. And for the fifth job, for the fourth job, I'm sharing it with anyone on the web, also in a similar manner. Okay, so now we can see the corresponding permission access levels and how they are reflected in the jobs list for the jobs with corresponding access levels. There are two other important concepts here that I'd like you to understand, and those are available from the left-hand sidebar. There are two views that we can navigate to. Number one is shared with me panel, and number two is shared publicly. And so number one is reflected in the shared column, and number two is reflected in the public column, right, for these jobs. So if you go to shared with me, I will be able to see the items that other accounts have shared with my account. The account that I'm currently using. So I'm currently using webinar account, for example, and I navigate to shared with me and I go to jobs. I will be able to see the jobs that Timur had shared with the webinar account. Okay. Now, here is a quick demonstration of how we can make sharing with another account. So here I'm starting with an entity, clicking on share and selecting another account. So now this top entity will be shared with another account, and I've also added external with a link during this video. But let's look at it in a bit more detail. So here is our home screen. Let's navigate to shared with me and to jobs. And here is the entity that the seminar account had created and now shared with my personal account. I demonstrated to you how to share the job entity with my personal account, and that's how I can access this entity by using my personal account. I go to share with me, to jobs, and I see the corresponding calculation. I can open it and see its details, and when I come back, I'll end back to shared with me. Now, the public jobs are public for anyone in the platform. By default, new accounts, new personal accounts contribute to the public domain, so we can see what everybody is doing. And new organizational accounts are hidden. So when there's private data enabled as an option, the jobs are not appearing in the public list. So to be able to see the publicly shared jobs, we navigate to shared publicly. And just like in shared with me, we have multiple tabs for different entities. So if we go to jobs and scroll down a little bit, we'll see the newly created jobs. This is the snapshot that I took yesterday. So you can see that April 16th is when these jobs were created. And if we change the number of jobs per page to 50, we'll be able to see more of that. So we can see that on April 16th, there were multiple jobs created in the public domain, and we can track and see what's going on. Okay. Now, when we collaborate with someone, it makes sense to exchange notes and some explanation about the entities that we work on. And we have included this functionality into the platform as well. So when we open a job that has been finished already, let's look at the finished job here. There is a way to add description to it. We can also add description to a job in pre-submission status and in a running job. At any point in time, we can add and edit the description of the job. To do that, we need to click on the I button, a button with the information icon, and then we can edit its description using Markdown language. Right? We can put links, we can put headers. It can be written as a perhaps small article. And here we can explain the approach that we used inside this calculation for anybody else to see. And when we look at this entity inside the list, we can enable its description. If we click on these three dots, we can select ID and description column to be shown. And here is how we can see the notes that other people have left, or we ourselves have left for this job. This is a convenient way to remember what happened in each of the calculations and exchange notes, exchange information. If something went wrong, your team members can help understand what exactly went wrong and communicate with each other through this description. Another important concept that I wanted to go through over the last few minutes is the entity bank. I went through this in more details in a previous webinar, but since it is related to sharing, I'd like to mention it here too. Account entities are collected per each account separately. So if two accounts create the same material, for example, silicon is present for all accounts by default. If two accounts create the same material, we have two entries inside the database for each of these accounts. But to be able to track unique entities, we have established the entity bank collection as well. So there is materials collection and there is materials bank. And materials bank contains unique entities only. So when we know that there are two identical materials, we create a single entity inside the materials bank. And we associate the entity bank ID with the original entities. That's how we can track how many unique entries, how many unique entities we have. The accounts that have public data and private data, they can have public and private data access enabled for them. And when they have private data enabled, all the bank entities that they create are accessible only to them and nobody else, right? So if an account creates a particular entity in the bank, no other account can have access to it. But when the account has public data, other accounts can see the entities created inside the entity bank. And that's how we have the list of workflows and materials in the bank that are accessible to multiple platform users because there are multiple people contributing to the public repository of data. All right. Okay, so here's the brief summary about the accounts of sharing. Entities can be shared within one account and only that account for secure and safe collaboration. Account teams have different permission schemes and allow members to perform actions on these entities according to those permissions. Sharing between individual accounts is possible, and sharing with all platform users is also possible. And external parties is the third option. Sharing with external, non-registered exabyte.io platform members. Entities support metadata, such as description or tags. And that's how users can exchange information with each other. And all unique entities are consolidated inside the entity banks. So this is another layer for sharing and collaboration that we support. All right, I think I'm done with this description. Do we have any questions? Feel free to raise a hand or just type a question inside the chat or Q&A. Looks like no questions yet. All right. No questions. Then thanks everybody. Thanks for joining us today. I will send out the video recording and the PDF of this presentation to everybody. If you have any questions, please feel free to reach out to me and we can discuss